Hey guys, these are the completion to your notes on the series and the parallel circuit and the differences between them. Alright, so tile it up series circuit, draw yourself a series circuit that has a battery. The schematic has 3 resistors. I labeled each resistor R1, R2, and R3, and then give yourself a good amount of room to talk about voltage and current in the series circuit. Alright. So we're going to add to this diagram. Say I have like a 9-volt battery. You know in a series circuit that the electrons, those are the people who hold the pretzels, that's the energy, they have to drop that energy evenly. They have to kind of split it up. They might drop 3 volts here, 3 volts here. This is just an example. They split up the 9 volts they gained. Now, they don't always split it up evenly, alright? Depending on what you plug in, whether it's a light bulb or a TV, maybe a TV needs more volts, so it'll get 4 volts, and if this was a light bulb, maybe it would only get 2 volts, and maybe somewhere in between the radio gets like 3 volts. So the voltage is not always split up evenly, but the voltage, write this down, is the voltage, voltage of the voltage of the battery is equal to the sum, that means adding together, of the voltage drops. Where does voltage drops happen? At the resistors or light bulbs. So the voltage of the battery is equal to the sum of the voltage drops. So if you add up 2, 4, and 3, you get 9. Okay. What we say, we could write that mathematically. Voltage of the battery equals voltage at R1, voltage at R2, and voltage at R3. If you add those up, dot, 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 if there was a 4th resistor, an R4, you would add that in and it would equal the voltage of the battery. What do we know about current? Well, there's only one loop, so current we label with the variable I. Okay, because C gets taken up by other things. So current is the variable I, and current is the same everywhere. If this is the current through the battery, IB, then the current I1 through R1, and this will be the current through the 2nd resistor, and here would be the current through the 3rd resistor. They're all the same, all of the currents in a series circuit, because there's only one loop, right? So current is the same in every resistor and the battery. Based on our diagram, that would be the current at the battery is equal to the current at the 1st resistor, and that's also equal to the current at the 2nd resistor, which is equal to the current at the 3rd resistor, dot, dot, dot. If you had a 4th resistor, it would also be equal. The current is the same everywhere. Okay. What do we know about if I unplug one of these bulbs in a series circuit? So unscrewing bulbs turns all out, right? What does adding bulbs do? Adding bulbs dims the other bulbs, right? So there's your series circuit. Let's look at parallel circuit. Okay, so here's your parallel circuit. Draw the schematic here. These are the branches. Each resistor has its own branch. We have the battery again. Again, I labeled the resistors R1, R2, and R3. Okay, So what did you find out in your investigation of a parallel circuit with voltage? What did you find out about voltage? So the voltage drops at each resistor equal the voltage of your battery. Let's use your home as an example. Since your home, your rooms are set up in parallel. Write that down. So coming into your house is 120 volts from the power company. Very powerful, very dangerous. A lot of energy. So how much voltage is dropped at every resistor in your room? Well, it's all equal to the voltage that's coming into your house. Every plug you have is the same voltage because they're all set up in parallel. So when the electron goes through here, it drops all of its 120 pretzels here. Another electron will go through R2 because this one's kind of filled up. So another electron will go through R2 and drop all 120 of its pretzels at your TV. And the next electron will skip the TV and go all the way down to your fan and drop all 120 of its pretzels at the fan. And on the way back, it won't go through the TV on the way back. It takes the path of least resistance and it just goes straight back. So parallel means that each electron needs to just go through its own resistor while it gets back to the battery. And they drop all of its pretzels, all 120, at that resistor. Okay, so voltage drops equal the voltage of your battery. All right. Just so don't stick your finger in there, because that's 120 pretzels. That would be quite a shock. Current, right? Oh, let's write down the mathematically for voltage. Voltage of the battery, VB, equals the voltage dropped at R1, which equals the voltage dropped at R2, which equals the voltage dropped at R3, dot, dot, dot. If there was a fourth resistor, it would also equal the voltage of your battery, or whatever your power source is. Okay, what do we know about current? Current splits up in a parallel circuit. So, if I have something like 12 amps is my current. So my we're going to say I total, IT, that's the total current. That means the current through the battery. Alright? If that is 12 amps, then it might split up something like this. Maybe 5 amps through R1, maybe 4 amps through R2, and I have 3 more to make 12, so 3 amps through R3. But whatever happens, the current, if these 3 fingers are 3 currents here and they add up to 12, they split up like that and go back. See that? It's kind of weird. Right? The currents, and then the electrons join up again, and then they split up and they join up again. Alright? So 5 plus 4 plus 3 equals our total current, right? So IT, that's the current through the battery. Total current equals the current through R1 plus the current through R2 plus the current through R3, dot, dot, dot. If there was a fourth resistor, that would be added in as well to the total. So the total current, we'll write down, equals the sum of the branches currents. There you go. What happens if you unplug a bulb in a parallel circuit? Unscrewing a bulb does not affect other bulbs. And adding bulbs does not affect the brightness of other bulbs. Why? Because if I add another fourth resistor here, it's still going to be 120 volts dropped at all of these. It doesn't matter how many you add. You could plug something in your room, and it doesn't affect the fact that 120 is going to be dropped at your other appliances. And that's the great thing about a parallel circuit, is in series, if you plug something else in, you got to steal voltage from the other resistors. It's got to split up. But in parallel, it doesn't need to split up. The voltage drops.